discussion on relational data model. Relational data model is a very important component of the whole course. Though we call it a database system, these we generally think of them as relational database systems these days. A database system is considered by default as a relational database system. So, this relational has become such a important thing. Before the advent of the relational data model, there were other kind of models in use, like network model and hierarchical model and all that. But relational data model is proposed by Cord in the 70s, and then it became very popular because it is very simple and elegant model with a mathematical basis. We will see those details as we go along. And Cord got Turing Award in 1981, much after it was proposed in early 70s, but about almost a decade later he got the Turing Award, which is one of the highest, it is the highest award in computer science. The introduction of this relational data model led to the development of the theory of data dependencies, and we will later on spend a lot of time trying to understand what are these data dependencies are. These are essentially to do with evaluating whether one particular relational data model for a particular application is better than some other design. How do we compare designs, database designs? So, it is in this context that we talk about what are called data dependencies, and then we define what are called normal forms, and then try to evaluate the designs based on these normal forms, and then come to a conclusion about what design to adopt. So, the relational database model led to this entire body of knowledge concerned with theory of data dependencies, and then how to evaluate database designs. Then as part of this relational model, we will also be discussing what are called relational algebra operations, and these algebra operations are the ones actually that get implemented. And finally, when queries given in SQL have to be executed by this relational database system, it is in terms of these relational algebra programs that implement relational algebra operators that actually work gets done ultimately. So, that what it means is that the SQL is a declarative style of specifying the query, and it will get internally translated into these relational algebraic expressions, and I was as I was mentioning earlier also, we then have an opportunity of looking at this relational algebra operators, and then try to make certain transformations on these algebra operations, so that they are the transformations are meaning preserving, but then will help us evaluate the expression in a much better way. So, optimization is possible. So, after the model has been defined, set up, and theoretical issues have been worked out, it kind of laid the development for this what is called a tuple relational calculus. Relational algebra is one thing, relational calculus is a different thing, and relational calculus is actually based on mathematical logic. It is based on mathematical logic, and that later kind of developed into SQL language. So, SQL SQL language first, and then of course that led to the database standard and everything. So, it is very important model to understand, and as I was telling you, a data model is nothing but a bunch of concepts that we will use to describe the database, and relational database, data model is used to describe the database at the logical level. Complete description can be given using relational data model. Okay, so let us now start looking at all the ingredients of this relational data model. So, the idea is actually pretty simple. That is also a very interesting thing, that is such a simple idea of a relation as we know of it in discrete mathematics, like as a subset of the cross product of sets, has indeed has such a great impact. So, okay, in the database context we talk of two things here. One is database relation scheme, and then the relation instance. Okay. A relation scheme will basically consist of the name of the relation, for example here, and the set of fields, or we also call them attributes. In this model also we call them as attributes, and but there is an important difference between the attributes that we have seen earlier and the attributes here. I will tell you that. So, these attributes are field names or column names. Sometimes we just call them as column names because it is tabular structure. Okay. And each of these attributes has an associated domain. Now, so here is an example. So, we have student name and the domain is strings, and roll number we also model it as a string, phone number is an integer, and year of admission is an integer, branch of study is a string. So, these are domains, these are attribute names, and then the whole thing is what is called one relation scheme. So, the relation name comes, and traditionally when write it these all the attribute names in parentheses. And now this what exactly is a domain? A domain is nothing but a set of atomic values. This is most important, a set of atomic or indivisible values. Okay. So, that means it is a single value, and we will not try to go into the parts of that and things like that. We will not assume that there has any components in it. We will simply deal it as though it is a single value, or atomic indivisible value. So, as against this, in the entity relationship model, when we were talking about attributes, for example, we talked about multi-valued attributes, composite attributes, and things like that, right. But here now, when we say an attribute, it is always assumed to be a value that comes from a set of atomic values. Okay. Now, you can so now this assumption is very fundamental to the relational database model, and it is so fundamental that it is actually called, it is later on in the when we discuss the normal forms, we give a name for that. It is called the first normal form, Okay. Good. So, that is what relation scheme is about, and then we have the relation instance, a finite set of tuples consisting. So, they constitute a relation instance, and then suppose we have a scheme like this, R A1 through AM, which are all attribute names. Then we basically have a set of tuples, and all this finite number of tuples constitute the relation instance. What exactly is a tuple is easy to see, because we are kind of familiar with that. The tuple is basically an ordered sequence of values V1 through Vm such that this Vi belongs to the domain of the corresponding attribute Ai for all I 1 to m. So, in this case student name Ravi Teja and roll number, some year of admission, phone number, etc. Okay. So, you can have dot dot dot. So, you can, it is not the infinite, it is finite number of tuples because it is a set and it is a set, a finite set, emphasize on finite set. A finite set of tuples constitute a relation instance. Okay. So, at this point of time, we are the only constraint we are placing here is that all these values, so this is a string. So, even though it has, it looks like having two pieces in that, it is a string. So, there is a blank character here. So, we treat it as a string, that is it. Okay. So, all these are atomic pieces of data and each of these things should come from the domain defined for that particular attribute. That is the only constraint we have and there are finite number of them. This is what is a relation instance is. So, relation scheme and relation instance. This should be obvious to you that there are no duplicate rows in a relation instance, right. Why is it that there are no duplicate tuples in a relation instance? Because it is defined as a set, not a multi-set, it is a set. So, set means we do not have duplicates. Later on, of course, when you deal with SQL tables, we for practical reasons we must allow rows, you must allow duplicate rows inside SQL tables. So, we will discuss that when we come to that. But right now from the relational theory, we will assume that this is a set of tuples and hence there is no duplicate tuples at all. Okay. Here is an example. Here is another example. Look at this. I am capturing the enrollment of students into courses. So, I am putting student name, roll number, okay, it should be same actually, course number and section number. So, let us assume that courses have sections and so course number, section number together is what a student has to enroll for or register for. So, in this case now this person Rajesh is registered for these two courses, whereas Suresh is registered for this course. Notice the way information gets replicated, because in order to record the fact that Rajesh has registered or enrolled for this particular course, you must record it like this CS3200 and then since the schema is there like that, we need to the point I am trying to emphasize here is that you cannot put CS3200 comma 3CS3700 here, because what does it violate? It violates our principle that the values here should be atomic. It should not be lists, it should not be arrays, or it should not be anything else, it should be atomic pieces of data. Because of that, you can see that we need to actually replicate the rest of the values and then change only this value. Good. So, here is another example. So, we will see a lot more examples of relations. Now, let us move on to the notion of keys for a relation. A key is defined like this: a set of attributes K whose values uniquely identify a tuple in any instance. In any instance, that is important. Any instance of that relation is what is called a key, and none of the proper subsets of this K have this property. So, it is in some sense the minimal set of, it is the minimal set of attributes that have this interesting property that their values will uniquely identify a tuple in the set of tuples. A set of tuples are there. So, we want to uniquely identify one tuple. What is it that helps us? If you look at this, for example, what is the key? What do you think would be key here? Can roll number be a key here? Roll number in this particular relation scheme, roll number is not a key, because roll number cannot identify a row uniquely. There are people who are doing multiple courses, and so roll number gets repeated in multiple rows, and so you cannot do that. So, you can see that actually roll number along with course number would serve as a key in this particular relation. Okay. So, here is another, so roll number for the student relation is in fact of course a key. There are no two students with the same roll number, and so in the student relation, which we have seen a little while before, roll number is a key attribute. Okay, what about roll number and name? Roll number and name. You can see that as long as roll number is there, you can throw in any other attribute, and then that set of attributes will anyway have the property of identifying that tuple uniquely, because it contains roll number, right. So, this set has the property of uniquely identifying the tuple, but it is not minimal, because you can throw away name. You do not need name actually, you just need only roll number. So, this set, though it can uniquely identify a tuple, it is not minimal and hence is not a key, because key is a set of attributes whose values uniquely identify a tuple in any instance, and none of the proper subsets of that has this property. It has to be minimal. Okay. Now, one important point about keys is that you cannot look at a database, a relation instance, you cannot look at a relation instance and then somehow figure out what could be a key, what is a key for that relation instance. It is difficult to do that. That is because in that particular instance, it so happens that we have a bunch of tuples and some attribute or a set of attributes, their values can uniquely identify a tuple in that instance. But then remember that the key is defined that it should not only just in that instance, but in any instance this attribute should have that property. So, it is something that, so it is something like an intrinsic property of the scheme. So, only the it can be determined by by understanding the meaning of those attributes, right. It cannot be simply determined by just looking at a particular instance of the relation data. Okay. So, it is an intrinsic property of a scheme, and so people who understand the domain only can actually identify what are the keys for the relations. Now, an important question here is that does every relation have a key? Does every relation have a key, has a key? Is it always the case that relation has a key? Having understood what is the definition of key, Now, can we make a statement saying that every relation has a key? You can, right? Okay. What is the worst case? The worst case scenario is take the entire set of attributes. The entire set of attributes will act like a key because it is a set of attributes. So, set of tuples. So, in any case the entire, if you take the entire set of attributes, that is the worst case, but oftentimes you will find some subset of the set of attributes which will have this property, and that's, and does a relation have multiple keys? Another question. Can a relation have multiple keys? Yes, it can, right? Nothing wrong. So, a relation can have multiple keys, and then it always has a key. So, a relation can have more than one key. So, here is another example for that. So, if it has multiple keys, we will call each of them as candidate key, the new term candidate key, we call all the keys as candidate keys. Later on we will see that one of the candidate keys will get chosen as a primary key when we move on to the implementation stages and things like that, but right now they are all keys. So, we call them as candidate keys. Now, let us look at this example of a book where ISBN number, author name, title, publisher, year are the attributes. I suppose you know what is ISBN number, right? It is a unique number given to all books, all it is an international standard and standard book number. So, that ISBN stands for that. So, this is, so let us make another additionally we can make an assumption here that just to illustrate the point, that books have only one author. It is not the usually case, but let us make that assumption, books have only one author. So, if that is the case, then there are keys like ISBN number is a key because it is set up like that, the it is international standard book number for books, and author name and title together serve as a key. No person will write two books with the same title, right? There will be some difference in the title. If you are writing a book and then you are revising it, then you will add the edition number to it. So, fundamentals of database systems, 4th edition is the title of the book. So, when you come up with the 5th edition, then fundamentals of database system 5th edition is the title of the book. So, people write books with different titles, and so author name title, because we made this assumption that author there is only one author, is also can serve as a key for this particular relation. So, we know that, so when we say this, it says that whatever be the instances of this particular relation, it is always possible to uniquely identify a book given the author name and title. Okay, that is what we are. Okay. So, this is the question I was asking a little while before. Does a relation always have a key? Yes, it always has a key, and the set of all attributes, in case no proper subset is a key, will work as a key. Now, another term we call something as a super key. What is super key? A set of attributes that contains a key is called a subset. Sorry, the key contains a key as a subset is called a super key. Okay. So, I gave you an example of a super key in the last slide. The roll number plus name roll number and name is a super key because it contains the key which is roll number for the student relation. For the student relation, roll number is the key. So, anything you add to that, then roll number, name, roll number, phone number, etc., they all will become super keys. So, if we have this notion of the super key, then key can be actually defined in terms of that. So, key can also be defined as a minimal super key. Key can be defined as minimal super key. Okay, super key is something which has this property that its values can be used to uniquely identify the tuple, and we are now adding minimality to it. That means no proper subset has this property. So, a minimal super key. So, in some books they introduce super key first and then define key in terms of super keys as minimal super key. So, so these are various terms that you will hear. So, primary key is one of the candidate keys is chosen for indexing purposes and things like that. So, we will see those details later on. Okay. So, this is a important idea, the key for a relation instance. I hope it is clear. Moving on, what is a relational database scheme? A relational database scheme D consists of some finite number of relation schemes and a set of integrity constraints. Okay. Now, what are integrity constraints? We will have to talk about that. First thing is, okay, it consists of finite number of relation schemes, and in addition it is just not these schemes, but we also need certain constraints. And what are these constraints? Constraints are certain necessary conditions to be satisfied by these data values in these instances, in the relation instances, so that instances constitute a meaningful database. Okay. Now, normally we talk about three kinds of constraints, one domain constraints, key constraints, and referential integrity constraints. So, in the next few slides I will explain these terms: domain constraints, key constraints, and referential integrity constraints. And then, so we call this relational database scheme. So, earlier we just had relation scheme, now we have database scheme. A database scheme is nothing but a finite number of relation schemes along with these integrity constraints, and database instance is a collection of relational instances of all those relation schemes which satisfy the integrity constraints. Okay. So, we have two things here, the relation scheme and relation instance, database scheme and database instance. A database instance is nothing but collection of relation instances, but not just any collection, but those that satisfy the integrity constraints. Now, let us go into a little bit deeper into what these constraints are and why do we first call them as constraints, and let us get into that. Okay. This basically the idea of domain and key constraints is to capture this notion of capture the domains and domains for attributes and the keys for the relation. So, we will see that now. So, so attributes have associated domains, as I already mentioned, and the domain is nothing but a set of atomic data values. So, the constraint here, what it specifies is that the actual values of an attribute in any tuple in the relation instance must indeed belong to this declared domain. Okay. So, that is the constraint. We would like to turn that information into this constraint, mainly because we would later on charge this relational database management system responsible for maintaining these, satisfying these constraints. Okay. So, that is the reason why we call them as constraints. So, the constraint, corresponding constraint basically stipulates that the actual values of the attribute. So, the data entry errors are often seen. Suppose you define a cell number as something which has exactly 10 digits, a string with 10 digits, okay, and no all numeric 10 digits, that is it, right. And then you see that somebody entered a 12 digit number there, then it is a violation of the constraint, right. So whatever is the declared domain, the values must come from, belong to that declared domain. So, we term this as a domain constraint. And in a similar way, we have this what key constraint. Basically, if you in the relation scheme, you say you have kind of declared or asserted that there are certain keys, candidate keys. Now, the corresponding constraints would be that if k is supposed to be a key for this relation scheme R, then in any relation instance R, little r, okay, we will use lowercase letters to indicate the instances and uppercase letters to indicate the schemas in general. Okay. So, in any relation instance R, little r on the schema R should not have two tuples that have identical values for these attributes of k. Okay. It is not just enough to say that okay, this is key, but the instance should satisfy that, right, otherwise it is a useless instance. So, none of the and in addition the key attribute should not have null values, should not have null is a special kind of a value we use in order to kind of indicate that we do not know the value or the value is not applicable, something like that. So, we use this null values. Okay. So, these are reasonably straightforward to understand, that basically we will use this notion of domain and key and then convert this into domain constraints and key constraints. So, that when you are specifying the database scheme, you would not only specify the relation schemas, but you will also specify all these constraints. So, that when you consider a database instance, it should be an instance of all these relation instances and together satisfying all these constraints. We will later on see, I mean we are also going to see one more important constraint called a referential integrity constraint. Okay. Okay. So, in order to introduce this referential integrity constraints, I must now introduce another term that uses the name key, but it is called foreign key. Let us look at this, what exactly are foreign keys. Okay. Now, it is often required, see, notice one thing, that in this model so far we have only one thing called the notion of relation. As a contrast to this, if you consider the ER model, we had entities and relationships. So, relationships between entities that captured the associations between entities. Okay. But now those relationships also have to be captured as relations in the relational model. Okay. So, we will later see exactly how that mapping will come out, but in general you can understand that tuples in one relation may have to refer to tuples in another relation. So, say R1 on capital R1 some tuple in that may need to refer to the tuple in R2. If that is the case, how does it refer? So maybe this is to capture the relationships between entities. Okay. So let me give you an example of that. But before we look at the example, here is a definition for that. So let us say primary key of R2 is B1 through Bj. Okay. So we are talking about two relations R1 and R2. So let us say R2 has some key called B1 through Bj. Then we will define that a set of attributes f of R1 which are A1 through Aj, same number of attributes, but their names may be different, same number of attributes which satisfy these conditions such that the domain of Ai is same as the domain of Bi, corresponding domains are same, corresponding domains for these attributes are same, and the values of these attributes are what we will use in order to refer to tuples in R2. Okay. These are the attributes we would like to use whose values are used to refer to tuples in R2 is what is called a foreign key in R1, and specifically we will say it is a foreign key in R1 referring to R2. Okay. Now, the one little twist here is that R1 and R2 can be the same scheme also. Sometimes you may use some set of attributes to refer to the tuples in the same relation. I will show you some example of that a little later. Okay. So, now let us first understand this and give an example of this, and there can be more than one foreign key in a relation scheme. So, this is also possible. So, we will call such a collection of attributes as a foreign key because it basically refers to tuples in a foreign relation. Okay, here is a simple example. The let us look at these two relation schemes, course and department. So, course has certain things, and then so course has course ID, name, credits and department number to kind of indicate as to what is the department that is responsible for offering that course. Okay. Now, here is department details. So, department relation, and that has department ID, name, who is the HOD and what is the phone number, probably the office phone number, let us say. Now, here is the notion of foreign key. So, these values we would like to now use in order to kind of refer to the details of what is the department that is offering it. So, algorithms is being offered by department number 1, okay, which is actually you can look up here and find out that it is in fact computer science department. And this DSP decision signal processing is being offered by 2, which is electrical engineering department. So, like that. So, basically what we are saying here is that it is possible that we will in one relation we have certain attributes whose values we will use in order to refer to tuples in another relation, and obviously the domain of this and the domain of that should be same, right. So, that is what we put in the definition, and if there are possibly two attributes or 3 attributes of that kind, then obviously the corresponding domains have to be same, corresponding domains have to be same, and so such attributes are what we call as foreign keys. So, in this case we have taken department number is a foreign key that refers to department, foreign key of course relation and refers to the department relation. So, this is how we enable tuples from to kind of link to other tuples. Notice that this is not a physical pointer, this is value based. This is not a physical pointer, right? This is not like, this is a logical thing, it is a value. So, if this value kind of represents what is the tuple it is talking about. Okay, here is, it is possible for a foreign key in a relation to refer to the, wait, I think, okay. It is possible for a foreign key in a relation to refer to the primary key of the relation itself. Let us look at an example. So, let us say you have a university employee with employee number, name, sex, salary, department and reports to. Let us assume that, just for the example's sake, that all employees are supposed to report to some other employee except possibly the top person of the university who is vice chancellor. So, obviously in this case reports to should be having values that come that are whatever is used for employee numbers. Let us say employee numbers are some 6 digit numbers. Okay. So, this reports to also should be similar 6 digit numbers, so that when you are looking at one tuple of one particular employee Ramesh, you can look at here and then find out what is the value here, reports to value, and that if you look up in the set of tuples will tell you who he is reporting to, who is his supervisor or boss, right. So, in this case we will see that the information about the employee, all the employees are in the same relation, and so the reports to has to basically refer to the same relation instance. It has to refer to the same relation instance. So, here is a foreign key that refers to the relation itself. So, here is the normal key and here is a foreign key that refers to the table, the same relation. So, I hope this is clear to you now, that every employee in okay. So, we basically are trying to capture as to who reports to whom. So, a bunch of employees might be reporting to one particular person and that particular person might be reporting to somebody else and so on. There is you can imagine that there is some kind of a hierarchy in the university, except of course the director or the vice chancellor, which will have a null value because he does not report to anybody. You can imagine that way. Now that we have set up this notion of a foreign key, we can talk about what are called referential integrity constraints. We will call them as RIC, referential integrity constraint, which basically is some kind of a guard for this foreign keys. So, let us say F is a foreign key in a scheme R1 referring to some scheme R2, and let us say K is the primary key for that particular R2. The RIC, what it says is that in any relation instance R1 on this relation capital R1 and R2, it should be such that any tuple T in R1, if you look at its F attributes, F is the set, F be a foreign key, right. So, either its F attributes values are all null or they are identical to the K attribute values of some tuple in R2. Okay. You get it? What we are saying here is that F is a foreign key in R1 and K is the primary key of R2. Okay. So, where the referential integrity constraint requires that in any relation instances of both R1 and R2, it should be the case that either these F attribute values of this R1 are all null, that means it is not referring to anything, or if it has some non-null values, then those values have to be identical to the K attribute values of some tuple in R2. basically what we are saying here is that there should not be any dangling kind of tuples, dangling references. Suppose you refer to something and that something does not exist, then you are in serious trouble, right. So, we want to make sure that there are no dangling references. So, RIC basically ensures that references to tuples in R2 from R1 are referring to currently existing tuples, they are all currently existing tuples, and so there are no dangling references. So, this is a very important thing, right. So, that is why we convert that into a constraint and then impose this as a referential integrity constraint, and then later on we will see that the RDBMS will be given the responsibility of ensuring that the database instance satisfies all the referential integrity constraints, and if it does not satisfy, what are the actions to be taken and things like that. So, here is a illustration of the violation of RIC. So, supposing we have seen this course and department relations earlier, right. So, let us say now we have somebody has come and introduced mass transfer as a new course and said that it is being offered by department number 4, and when I now look up in the department, there is no department with department ID equal to 4. So, this is a reference which is dangling, there is no department number 4 and this fellow is introduced, either it is an error here or it is an error here, we do not know, right. Either in fact there is a department number 4, but its information is not recorded here, or actually it is being offered by department number 3 itself, but it is wrongly entered as 4, etc. So, these are possibilities. Of course, you might say that okay, I may probably be able to figure out what is the department from the course number, but we are not allowed to look into the values there, remember that. Yeah. Let us say, so okay, this could be something else, right, for example. So, in general we are talking about one relation, tuples in one relation referring to tuples in another relation, and then whatever is being used as a attribute to refer, its value should either be existing as a value here or it can be null. Supposing I do not know what is this particular course, who is offering this course, I am allowed to enter null there, in which case it is not a problem, it has to be updated later. But if you enter 4 and then 4 does not exist, then it is a problem, right. So, that is why in the definition, if you notice clearly, we are saying that either the F attribute values are all null or they are identical to the K attribute values of some tuple in R2, to make sure that there are no references to non-existing tuples. Okay. So, that is what referential integrity constraints are about.